Hi everyone, my name is Srikanth from Ericsson and my colleague Daya from again Ericsson. Today the topic of the discussion is IPv6 in tenant networks. Um, so, so these are the high-level list of features that we wanted to address as part of this feature. So as you see here, the prioritization is what we came up with couple of discussions, but we can change based on your feedback. So the first and foremost is we need to support the auto configuration of this address assignment for the IPv6 host, which is a Slack based. And then the neighbor discovery protocol support is again another basic feature of IPv6 that we need. And in addition to these two, we need the basic L2 east-west forwarding between the virtual machines in the same tenant network or between two networks of the same tenant, that is L3 east-west forwarding. And we also put L3 north-south forwarding for the VM external connectivity in both directions. And the last four are, we thought they can come after these five features, which are DHCP v6 based addressing assignment to the host VMs. Either it could be stateful or stateless. And prefix delegation is another feature that is optimization wise, or to avoid the neutron manual configuration, the prefix delegation will provide you the automatic configuration of the prefixes from external router. Similarly, L3 VPN and BGP updates is another feature that we wanted to support with IPv6, and last is service function chaining. So these are that we could think of, and if you feel something else need to be added, please let us know, we can take that. So we have just done a quick impact analysis of these various functionality that we are looking, and this is we captured them here. So for V6 address assignment using the Slack, this is the fundamental feature of functionality of IPv6, which touches the Open Neutron ODL plugin that we have today needs to be updated to take some additional attributes that we need for IPv6. And on the OpenDaylight side, to handle those events. So here are the few events that I have listed here that require some special handling for IPv6. For example, when a subnet is created, we need to handle the additional attributes like IPv6 or route advertised mode and IPv6 address mode. These are the two attributes that will tell you what is the address assignment mode that needs to be used by the host. Either it could be the Slack based or DHCP v6 based. So this is one impact, one event that we need to handle in OpenDaylight side. And similarly, when a router interface is attached to the IPv6 subnet, this is when we need to start advertising the route RA messages periodically based on these flags, this information. So you need to mention what are the IP management mode, whether it is Slack or DHCP based or WO flags. There are some certain flags that you need to advertise in the RA. Along with this, you need to publish or announce the v6 prefixes that are present on that link local. Similarly, this is v6 prefix that needs to be used by the host VMs for its address assignment, along with the on-link and off-link information.
So which component do you expect a split rather than?
So I will come to that. Yeah, we have one slide.
Do we know if these come in through Neutron to us, or we need some static configuration for any of these?
So yeah, that is one part we need to explore. So the IPv6 RA mode and address mode will translate into the same WO flags. The v6 prefix we will get through the subnet. Only this on-link and off-link we need to see whether Neutron has some information to tell us whether it's on-link and off-link. And MTU information will come through along with the subnet. Our default gateway is again comes through the subnet. Yeah. So yeah, once the router interface is attached, we need to start periodically announce this RES with this information. And moving on, when a VM is created and attached to this IPv6 subnet, here we need to do some exploration on how today Neutron's current handling when a VM port is attached to the IPv6 subnet.
So do you see, are you seeing any issues? I don't know any issues right now. So in that area.
Which one? Sorry, I missed.
So you create a VM port in a subnet.
Uh-huh.
So do you expect or are you seeing any issues right now?
In Neutron or?
Yeah, in this slide you are talking about Neutron.
Correct. I mean, I don't know what is the current handling of Neutron, so I need to explore, or we need to explore on what is the current handling of Neutron to understand. So the main concern that we have is in case of V4 port attached, we believe Neutron assigns a IP address to that particular port. But whereas in case of V6, we want the host VMs to do Slack procedures to assign the address. So that is, there is some differentiation between V4 address assignment and V6. So that's we need to understand. If Neutron assigns an IP address, how does it match with the host Slack derived IP address?
As well, Neutron core side itself is quite good thing. And it's good for DP2 support, so I don't expect any
Issues.
major issues.
Correct. But one comment I heard is, can it support V6 only ports? I heard today it supports V6, V4 dual port, but can I create a one port assign only V6 as addresses? Is that supported or not? We don't know that.
I guess it does, but
Again, yeah, we can explore these things. Yeah.
Little bit of investigation.
So you're assuming that the router advertisement will be sent from Neutron over the Neutron plugin?
No, we that as part of the design proposal we will see. Yeah, either we wanted to do it as part of the ODL router component, or any other component that is on the network periodically publishing. Current proposal is to do the ODL publishing these, sending these RA messages periodically.
What if there's a VM that acts as a router, performs router advertisement? Do you ignore that?
That is what OPNFE team has brought up yesterday. They have a concept of service VM acting as an IPv6 router. So we have not considered that, but we could definitely, that is as an alternative approach.
So we would need to figure out whether it can only do the control protocols from the service VM, but the data S3 forwarding can be done in a distributed manner. So that's where the value of SDN is to be, that if we do the S3 in a distributed manner, right? The way we do DDR with before.
Exactly, but my concern would be that if you don't catch the router advertisements in a situation that they're not neutron related, so they come from the VM, don't know what the VM does,
Right.
then you can't do optimizations that we do today, for instance, for ARP. Right?
Correct.
So we basically eliminate all the ARP broadcasts today,
Right, right.
whereas with this type of mechanism, you wouldn't know even, you wouldn't know the IP addresses of the VMs that we call from router advertisements on them.
I mean, we could probably do some packet instance loop on them. If, let's say we do run a VM in a control VM, right? Potentially we could, snoop on these from some switch
So
and,
that was my
and
question,
learn
if we
these.
would snoop, so would be a specific rule for snooping router
Yeah,
advertisements.
exactly.
We still know the MAC address. At least we can insert the MAC address based rules and only punt the route solicit messages only to that.
So there could be a significant impact because when you see one router advertisement, you have to populate IP addresses for all the VMs on that specific connection.
Correct.
It would need to be repeated at least.
Mm-hmm.
Yeah, I mean, we want to make this sort of a working meeting and see what might be the best approach forward. This sort of just captures what needs to be done first.
Correct,
What
yeah.
is- what
Yes,
is there
yeah.
and then what needs to be done there.
So in addition to that, yeah, we need to respond to this router solicitation messages from the VMs whenever they come from. and along with that, we need to plumb the open flow rules to handle these router solicitation messages either to OpenDaylight or to the service VMs, whichever approach we go with. The second major area is the neighbor discovery protocol support. So again, this is, we need to have some rules put in the switches to punt any of the neighbor solicitation messages that are sent to this special node solicited multicast, either to the ODL or whoever is handling this neighbor discovery processing. And we need to have this mapping of the IPv6 address to the MAC and reply with the neighbor advertisement with the corresponding the MAC information. Similarly, there will be a neighbor solicitation for the router IPv6 address itself. When VMs want to send a packet outside of the network, they will send it to the gateway address. So we need to handle the neighbor solicitation for this particular IPv6 address.
So this one complication that is thought about, if you use a service VM
Mm-hmm.
and you snoop on the router advertisements coming from there, you would not get any tenancy information. So if you just try to use the MAC and IP information, you would, today we get the tenancy information from the port, right?
Mm-hmm.
The port is connected to and the neutron mapping. You wouldn't be able to get that from looking on the wire. So how we support multi-tenancy?
So maybe
MACs and IPs. No, you need to support overlapping MACs across tenants, across network people, right?
Yes, there would be separate layers of network.
but how does the service
These are
VM?
all layer 3. I mean, the router advertisements are all multicast based, right? They are not at the layer 2 level.
But not that.
Not necessarily, right?
Or the port they, you know, the port they come from.
No, but
The solicitation you would know, but the advertisement would come in from this service node, right? So if the service node is answering for these, how would you know which tenant it is answering to? From the wire you won't be able to make out, right? Or you would have need to correlate the solicitation message and the response, but there's nothing in the packet that gives you that information. Right.
yeah, maybe we need to understand how they are addressed in the service VM based approach.
Yeah.
So she's,
For tenant?
oh, okay.
Okay. So then how did you send the right, send it to the right VM? Or, it's just a layer to the domain in which you flood?
Do you know if the OBS is capable of responding?
That is another investigation we have to do, whether OBS can itself respond to these neighbor solicitation messages. We have not.
The trick with ARP is
Correct.
itself.
Nicira extensions we could make use of for the ARP, whether they can be helpful with the ND.
Because it's an IP packet. It's more complicated.
Hmm.
So it's an S3 packet, right? So I think that someone also.
Reversing next.
Yeah, settlement takes.
Okay.
Unless OBS has some tricks up its sleeve itself that you could leverage.
I guess even with for the ARP, we are doing something with checksum, isn't it? In the
No,
floor.
ARP doesn't have checksum, right? It's a layer 2.5 sort of package. So he just replaced the source
Source.
and reply.
It's just math.
Hmm.
Yeah.
Hmm.
It's
Hmm.
the same packet.
But it's
Okay.
not an IP packet, right? So there's no issue there. So this would be an IP packet. So unless
Correct.
the OBS has mechanisms in open flow to compute a checksum and send it out to the Linux stack.
Hmm. Hmm. Yeah, then the other neighbor discovery usages like duplicate address restriction, we feel there is no special handling required. And for support for neighbor unreachability detection is more of a host feature, so no special handling.
I'm just thinking on the fly here.
Yeah.
So that, let's say we also support a learning mode where not all addresses are known to us from Neutron, so especially if it's supporting Slack, right?
Mm-hmm.
Then we would probably need to do a flood for that and check if nobody else is. So especially these VM Max can all, they can be overlapping, right? So that.
But within a tenant, at least we will not have, right?
It's not guaranteed, right? Usually it's true, but it's not guaranteed. Especially like NFC use cases that we are looking into.
Mm-hmm. Mm-hmm.
You can have an application configured max. So there's no guarantee that, so only guarantee is that within an L2 domain they will be easy, but
Correct.
not even within the tenant space.
Mm-hmm.
So
Okay, so in that case, we need to
we might need to do some
either flooding.
flooding and check. And
Yeah.
let the DAD basically go.
Correct. Correct. Yeah. Correct. So there needs to be one additional role that takes care of that flooding.
Do you know how multicasted, either before multicasted happens?
Today it is a flood. It's a broadcast. Yeah.
Because of V6, it's a special multicast, you could say, or like limited distribution, the MAC access doesn't bring speed.
Correct. We have multiple types of multicast, all host multicast, all routers multicast, and node solicited multicast.
Node solicited is basically
Is a
function of the MAC access of the node.
correct. It is like a
It's
unit,
almost like a
unicast. Yes. But yeah, the proposal is if the OpenDaylight is going to handle, all the packets will be punted to the OpenDaylight irrespective of whether it is whichever multicast it is.
Just for maybe that.
Yeah, for some of these cases we need to add special, yeah. Then moving on in the functionality wise, the L2 VM to VM forwarding, we believe that there is not much of impact because of V6, and networks existing L2 logic should take care of this unless you feel something else we are missing here. From the pure L2 side, it should work. And in case of L3 east-west forwarding, the necessary routing and forwarding table flow rules needs to be plumbed in the pipeline. And the other issue with the L3 north-south is one area that we need to understand more on how this is handled in the existing Neutron, and to see what we have to do from the OpenDaylight side. So this is when we say north-south VM to the external connectivity in both the directions. Whether one thought here is whether when the Neutron subnet is created, the prefix that we provide in the Neutron, if they're already globally unique prefixes, then nothing much, it's no different from locally unique addresses versus globally unique. But my question is, if Neutron, how does Neutron ensures that these addresses are advertised to the outside so that they are reachable from the external networks? In case of V4, they use the floating IP concept, but in case of V6, if they use this globally unique addresses, do we need to do any advertisement of this one, or it is assumed that these addresses are configured in the external router so that they are taken care of, advertised by the router, and we can assume that they are reachable?
Lakshya, do you know whether there's any local versus global scope?
But we're trying to use global.
Always local, right?
So no floating IP.
Correct.
So any of like one supporting
I think it's normally there's no map for IPv6.
We think you don't need it.
That makes sense.
So if it is global, then we also can assume that they are advertised to the external networks and we are reachable on those IP addresses.
But who would take that responsibility, right?
It looks like the tenant has to,
Configure the
Correct. Yeah, that tenant has to do that.
But you still need to take care of the roles of the route, neutral router, and VPN. So, like there's, for instance, a router advertising from an external router. On the external network, you need to have an IP access to the router,
Hmm.
things like that.
Correct. How do we make our router as the next hop from the external router for all these prefixes? Yeah, so these are the few things that we need to investigate on how it is done in Neutron and what are the additional things that we need to do from the OpenDaylight side. Similarly, once these are globally routable addresses, we might need to entertain the neighbor solicitation messages coming from the BRX from the external network when anybody asks or address resolution for this. And as you pointed out, there is no floating IPs, so no SNAT and DNAT rules that we will leverage in the V6 routing.
That also makes you wonder, what does a VPN mean in that context?
Okay.
To use local,
Mm-hmm.
how do you contain VPN? With all external connectivity, all global is
Yeah. So these are the things that we may need to further investigate to address this particular functionality. Yeah, then L3 VPN is again, we don't know much what is L3 north-south versus L3 VPN if it's everything is globally routable. We thought that there might be some impacts on the SFC. Again, we have not spent much time to understand what those impacts, but we just kept it as a placeholder. And any impacts on the security groups also, we have not gone deep into that. So these are the high-level functionalities or features.
basically translate to end host fixed IP assignments. But if SFC is all coming from, the VM sensors are coming from OpenStack, I guess mostly.
Correct.
The SFC configuration you have.
Okay. Mm-hmm.
Specification of the
One thing you mentioned IPv6, right? What is the impact on company?
Again, the advertising this IPv6 prefixes into the external networks, we may need BGP, MPBGP support.
So, okay, so the VPN service in OpenDaylight is pretty much a component which provides you in the data that is over to virtualization. What happens is we have BGP format stack which goes over there and then the data goes up to your website. So it's still IPv6 format.
Right.
It'll be interesting what are the implications of IPv6 on this.
But why is IPv6 will impact the function of the VPN?
Okay, so for example, on the enterprise side, enterprise will have IPv6
Right.
right? So when it is on the data center or cloud side, so you need to have those IPv6 first be pushed onto the BGP side so that the tenants can also get IPv6 address and then they are in the same address context center or whatever.
Right, but this is separate, right? These okay, they're separate.
Yes, they are separated basically. The idea is from a V6, if you want to enable V6, what is the next thing you need to do from VPN perspective?
No, it's
Yeah, impact of this V6 on the L3 VPN module.
On the VPN module.
So this is a high-level proposal to address some of these functionalities. So as you see here, there is a new component that is getting introduced as V6 Route Manager that handles some of these V6 host-related protocols like route advertisements and neighbor discovery or ICMP V6. So this Route Manager will interface with the Neutron northbound in the northbound direction and with the southbound renderers on the southbound. So the distribution of functionality here is the route manager we are thinking of to purely to address the host related protocols with network or L3 VPN taking care of the L2 and L3 based forwardings. And particularly for the DHCP, we still wanted to use the neutron setup in order for whatever we are using for the DHCP v4, we wanted to extend for the v6 also. So this is the high level proposal. As you are suggesting, instead of this v6 route manager, if we have a service VM on this per service VM instance per tenant network, we have to see if it addresses all of our functionalities, so that that can be as an alternative solution here.
My concern would be in terms of scalability.
Correct.
If you have A, data packet going into your controller, B, these could be used for attacking the controller, because the controller will never discovery It's not consistent with the PVR solution in IPv4.
Correct. We have listed down the same concerns, that scalability is one of the concerns. What is the packetings that our OpenDaylight can handle? And so the So the reason we took this proposal is already there is some work done, and that v6 route manager is existing today. So if you, the current status is this route manager with base functionality for the route advertisement and ND is available in one of the branch of the OpenDaylight. So it will give you a good start for us to proceed, but the one of the key concern is whether are there any scaling issues with this approach. And L3 VPN continuing with the BGP VPNs. So at a high level, message flow is like, as you see here, route manager coming in between, in addition to the network that is interacting with the northbound, neutron northbound. So the route manager will listen to all the neutron events from the northbound side and all the open flow packetings from the southbound. So it currently handles creation of the subnet for v6, where it gets all the v6 related information and stores it. And whenever I attach a router interface to the v6, whatever information it can fetch and store it. Similarly, creation of the port, update its database. And when a VM is created and attached to the v6 subnet, the route manager will do the periodic route advertisements with whatever information that is applicable for that tenant to the outgoing port, so that the bridge, the switch will forward the route advertisement messages. Similarly, if VM sends a router solicitation message, it will be responded by the route manager component. And all the host protocol related open flow rules will be taken care by the route manager. So in this case, neighbor discovery rules are getting pushed by the route manager, while network taking care of the L2 and L3 forwarding related rules. So here I just for a sample example. So neighbor solicitation coming from VM, which will be packet into the ODL that is listened by the route manager and responding with the neighbor advertisement message output to the port. This is one sample message flow with the route manager based proposal. Yeah, as I was mentioning, one of the reason for this is there is already some work done by Mohnish and his team, which already handles the route advertisement functionality and the neighbor discovery. Currently, the code base is on a separate branch and rebased with master recently. And they have verified the IPv6, neutron IPv6 related events are received by this module, like create network, create subnet and attaching router to the subnets. And on the southbound side, they have verified the packetings for the neighbor discovery, and the router solicitations are working with this component. not fully integrated with the OVS, the network module, which requires some work here, and the population of the rules in the OpenFlow side needs to be done. There is some work. We are assuming that there is no special handling inside the OVS DB southbound renderers for IPv6. It is mostly agnostic of v4 versus v6, but if we have any, we need to capture that.
So the protocol itself seems to be agnostic of schema.
Correct.
But
Oh,
in our connection management entity within the controller, well, that's a control connection.
yes.
Most of the data fields are all strings.
It shouldn't matter for v4, v6. Yeah. This is one of the things that we wanted to do to address some of the security concerns you were thinking, so that not host VMs to respond for router solicitation versus routers responding for the neighbor solicitation kind of messages. So add some anti-spoofing rules to the host VMs.
That's one way you could control the DOS.
Yeah. And design choices here, some of them we need more detail out, but yeah, the concern of the scaling is where to handle this neighbor discovery protocol messages, auto respond using OpenFlow rules versus punt to controller. If punt to controller, are there any scaling issues that we need to handle? Similarly, for DHCP v6, should we follow the v4 model, or should we have a inbuilt ODL? And this will be one of more of alignment tasks that we need to eventually make Route Manager aligned with the new architecture of the network. Again, it depends on the timelines of the network new architecture. Yeah, this is all we have to present, but we can have any questions or any interactive discussions we can do. Yes, we have 10 more minutes.
So how do you expect to send out advertisements? So are you
This one?
send, yeah.
This is the
To each compute also, or just send packed up to networking node and then broadcast?
the proposal is to send to the each compute node BR int. Yeah.
There's no networking
Node inside the.
running a neutron node.
So we can produce.
So we can
Yeah.
introduce one.
So at this point, it's not obvious which is better.
There's one way which you could set it out to a given switch and set up a flow loop on the switch to do the annotation. You do a packet out to a given switch and that might reduce the total control.
Sounds like it would like sometimes that would be coordinated with each switch. I don't think we just really
Correct.
getting up to a certain approach.
Yeah, the same functionality that we are running in the ODL, if they can run next to the switches, they can do the model. Yeah.
What wouldn't stop obviation in the world?
Correct. Yeah. Mm-hmm.
There would be some kind of
So the service VM type approach would work for all types of applications in the network.
yeah,
So, yeah, you could deploy sort of service VMs for tenant.
what is the OpenStack approach without understanding?
OpenStack spins up this Radwid daemon per tenant, similar to the DHCP agent which takes care of the route advertisements. But neighbor discovery part, I don't know who handles in the OpenStack. Okay, it's sent to all the broadcast VMs. Yeah.
What about the multi-service? Expect multi-service implementation in the packet?
Not necessarily. You get multi-customer broadcast. Not
Correct.
Mm-hmm.
You have maybe great mentioning about data being stored. So you expect to have multiple types of data. So yeah, okay.
Sorry, I missed that.
So I mean, do you want to have a multiple types of data? Right now, OpenStack we don't only allow single S3 client. So there's no mechanism like Tenant to
Okay.
S3 is not yet much.
Mm-hmm. Okay. Again, I don't know the many details on this Radvid OpenStack support, but I understood as per tenant they are spinning up this Radvid namespace similar to the DHCP. So here, in case of service VMs, who spins up that VM? The Neutron, or sorry, OpenStack itself will create this service VM, or sorry,
Manual.
currently it's manual. Okay. Yes, sir. If any other queries,
So we need to look at the distributed approach with
correct, yeah.
or we should go with a centralized approach to start with and then push it down to agent sort of.
Later, yeah. That's what to start with. Maybe the centralized is a good start, but.
Just to get the function.
Mm-hmm.
Because we're going to need something anyway, right? We've got the OpenMP deployments, which will have that service VM.
Correct.
We're going to need something centralized. We're going to have something. But does it look like, can we do just a simple configuration so we can support both? Is there enough?
So the current OPNMP deployments, those service VMs are not just control plane entities. They're also doing data plane forwarding. They're like routers. They had a hop in the network, right? Whereas what we would probably be looking at is just have control entities running as VMs, but do the data planes to flow, right, in a distributed manner. So it would differ a little bit, I think, from what the talk that you guys have done. And within this approach, then the question is, control entity, should we start with in ODL and then push it down into some agents to get more scale, or
Do you, is that a question or you just?
No, we had.
it's an open
Yeah.
question, yeah.
And we had discussed, probably just start it in OpenDaylight,
Yeah.
see how it works, push it out if needed.
And then push it up the next week. But I don't think Monish currently is using anything from RADBT, right?
No,
It's from scratch.
from scratch. Yeah.
It's implementation from scratch.
As opposed to what?
The RAD.
We're using the daemon that OpenStack has. They have a RADBT daemon which runs the what we control plane protocol.
So the component, this route
I'm
manager.
sorry, I went to another session.
Yeah.
Are you proposing to use that?
No, we are just exploring whether this route manager has any functionality from the Radvid daemon, or it's fresh built from scratch. Is that the question?
Currently it is, but I was wondering, were you proposing that we could actually use some of that?
We could look at
Yeah.
it. Give us the full compliance, RFC compliance, all those things that sort of be taken care of automatically instead of re-implementing everything.
Maybe it would that kind of makes sense.
Mm-hmm.
Probably we should just look whatever currently we have, and then there's any drawback or advantage. If it's common code, that'd be easy. Everybody made a code, and we use the same code. More people will utilize the code.
Correct.
That would be a better idea.
Yes, yes.
already, right?
Yeah.
That is
Just,
the code.
need to implement it.
Yeah.
Any?
Any other thoughts or input from perspective, anything?
We wanted to discuss on this L3 north-south handling in the Neutron. Can we talk to you or? Yeah, because I wanted to understand how is this handled in the Neutron.
Yeah, so it's like I don't see any major, I don't see any major issue. So we can just work.
Okay. Okay. Yeah, we just want to understand the pro.
Let's say we want to do Slack, okay? And Neutron is configuring the Neutron port. What would it send down with the port create? Would it just send a subnet and MAC?
Subnet on
Subnet and MAC with no IP in there.
IPv6, yeah, right.
And then so the ODL controller, let's say we're running the route manager in ODL. ODL would need to build out that IP address based on the prefix with that and reply to.
No, ODL would not build, right? The address will be built by the VM itself.
By the VM. But ODL also needs to respond.
No. Yeah, it does. It just send out the route advertisement with that prefix and let the VMs. Yeah.
Go back to the previous hatch.
Oh, the picture?
Yeah. I mean, I'm new to this network. What is the role of labeling and rich EX? Again,
What is the role of
BR and BREX.
That's on
the
the
BREX? This is on the data plane. BRINT is handling the east-west traffic between the VMs, VM to VM. BRX is more for VM to external networks, external network connectivity. So today, at least, floating IP is sorry.
Well, even the floating, everything's really done in BRN. I think BRX is just almost like just a transparent, just a bridge, right?
Okay.
I was asked, I wonder why we even have it, whether we can
Okay.
do anything with the BRN.
Well, the overlay, the overlay endpoint, BRE, something.
BRE.
No,
I mean, BREX.
The overlay endpoint is also BRN. The VXLAN, everything is done here.
so why do you need text?
Yeah, that's where I thought it's
Yeah,
for the
yeah,
external.
because I think it was there with the OpenStack OPS
Correct.
solution, and
OpenStack
it was
is
just
there.
kind of preserved.
Mhm.
So I don't know, I just had that question, I wonder why we even have it, because it's just an extra bridge from the connecting BRN to really to external,
Well,
to the external network.
yeah, well, our solution that we use BRX is a normal.
Okay.
We allow it, to connect for the north-south traffic, but we don't program for
Does
it.
anybody
We-
program flows on it?
Normal.
Okay, so all these are done by here itself then, the floating IP, SNET, dinner, okay.
I'm sorry if I lost the names, but yeah, everything's done on BRN
Mm.
and BRN. So I don't know if it serves a purpose for, multiple ports or, but even then you need to be able to catch loops.
Multi-mix,
Yeah.
and each of them would be different depth endpoints. Then you need to know, or a single step on multiple ports.
Are you asking?
Yeah.
I was wondering if there was any use case for the BREX, but what value does it add versus just adding that external port right to BRN?
Yeah,
External network is managed by cloud administrator, not by Neutron. So it should be out of control of Neutron. And it can be configured by whatever server you want to do. Basically, basic concept. So this concept is external network is already set up by server. That is external. That's by definition. And it just and how to managed by Neutron. It's being managed by Prioritization.
But BRX is managed by Neutron, right?
Yes, yeah. So the concept is, yeah.
Okay.
There is some implementation, implementation case, but basic concept is separation of management.
So it enables the admin to do some different configuration
Yeah.
on VREX without messing with
BRINT maybe.
VREX.
Then the VRX should also.
Or VR common. Yes,
So then VRX should be technically configured by the application, not by ODI.
Basically, so.
Well, but you still gotta, yeah, it's kind of like the line that was just, it's an interface. You know, they'll bring up the, you know, in Neutron, they'll create VREX, you stick an interface on it. And everything outside of that, you know, that's provider network taken care of. And, you know, that's where OpenStack and OpenDaylight stop.
So when we have to send to, so from a forwarding logic, all the SNAT DNAT gets run by BRX and then packet is handed over to BRX.
Yeah, looks like there is a patch port between BRINT to BRX. There is no flow rule on BRX.
Yeah, VRX got all the plugs, yeah. You just you show it out that patch port. It's VRX, it's normal. And it does normal switching.
So maybe I guess we are done, right? So the next action plan is to explore the other options, or we will get started with the centralized approach. And
Yeah, we can start, come up with, but we can look at whether that will be or.
yeah, those things we will
And then
explore.
follow
Yeah.
the centralized approach and also look at some of these, whether some local are NDF response.
Okay. Okay. Thank you, everyone.